This morning's first keynote speaker has a wealth of experience in national security policy from numerous perspectives, including the private sector, academia, and the U.S. government, where she served for more than 15 years in senior roles. Here to introduce her is Kathy Selby, Chief Executive Officer of Gravity.
So it is my pleasure to introduce Katrina Mulligan, who leads National Security Policy and Partnerships at OpenAI. Katrina leads efforts to ensure the development and deployment of advanced AI technologies align with national security matters. In this role, she works closely with government partners, defense and intelligence stakeholders, and the broader policy community to develop responsible AI frameworks that anticipate the unique challenges and opportunities AI presents in the national security domain. Katrina brings a distinguished background in national security, law, and policy, having held senior roles across the U.S. government, including the Department of Justice, the Office of the Director of National Intelligence, and National Security Council. Her career has focused on bridging the gap between emerging technologies and the evolving threat landscape, an intersection increasingly critical to the work of the geospatial intelligence community. At OpenAI, she's helping to shape how foundational AI models, such as GPT-4, can be applied in secure, ethical, and effective ways to support missions ranging from situational awareness to strategic decision-making. Her insights are especially timely as the GEOINT community explores how AI can enhance operational capabilities while navigating new policy, governance, and risk considerations. We're honored to have her partner with us at GEOINT Symposium to share her perspective on building trusted partnerships around AI innovation in service of national and global security. As we heard yesterday, partnerships are essential because we can't go it alone. Please join me in welcoming Katrina Mulligan.
So my focus for the next 30 minutes is going to be on making some things about AI that may feel a little bit opaque to you really, really tangible, so that each of you walk out of here knowing more about what is really happening with AI and why you should care about it than you did when you got here. I love the analogy that you don't get fit by reading about working out. And that's true with AI too. You don't get smart about AI without actually using the technology. And so what we're going to do today is I'm going to spend some time showing rather than telling you about what this technology is capable of. And I'm going to hopefully inspire you to think a little bit about how this technology can transform workflows that are really familiar to those of you who are GEOINT enthusiasts. So we're going to start we're going to start with some level setting about what's true and no longer true about AI. Which changes with some frequency. We are going to look at some practical applications of this technology in the national security context. This is going to include some demos that I made just for this audience. And then we're going to wrap up with a peek into the future, and I'll close with where we see the technology going from here. OpenAI was founded in 2015, and our original goal was to research, develop, and release cutting-edge AI technology, as well as tools and best practices for safety, alignment, and governance. Today, hundreds of millions of people already rely on our tools to make their lives better. Over 500 million weekly active users, which equates to roughly 10% of the planet, is using our technology every single week. We've just surpassed Twitter, also known as X, as the 5th most visited website in the world. That happened last week. So a little bit about me. You've already heard a little bit, so I'm not going to restate the pieces you already know. But I started OpenAI's national security team just under a year and a half ago. And having been at OpenAI for 15 months, that means I've been at OpenAI for longer than 2/3 of its employees. But the 20 years before that were a lot like yours. I served in a lot of 3- and 4-letter agencies. I won't restate them all. There were a lot of acronyms in my introduction, but one of them you didn't hear was NGA. That's something I've always regretted because I always had a bit of an institutional crush on NGA, and even to this day I tell people it is the best kept secret in the intelligence community. But the key takeaway about me is that I'm basically an old lady who likes birds and a chronically late adopter of technology. I am not the kind of person that you expect to find at OpenAI. I am literally the oldest person in every meeting that I'm in, and prior to coming to OpenAI, I had never sent an emoji in a work communication. But that makes me a really good person to bridge the gap between your world and this new one. And for the next 20 minutes or so, if I do this right, I'm gonna help you learn some really helpful things about this technology. So let's get into it. So I want to start here by level setting about where we are in the AI movie. Some of you probably feel like AI isn't really new. I often hear from government stakeholders that they've been exploring and adopting AI and machine learning in government for years, decades even. And that is totally true. Machine learning concepts emerged back in the 1950s. Early algorithms with pattern recognition and detection emerged in really the 60s and the 70s. We made some neural network advances in the 1980s and the 90s. And that improved the ability of computers to classify images and even outperform the world's leading chess champion, which is a marker that maybe some of you know. In the 2000s, the term deep learning is coined, and in the 2010s, we start to make some really major gains. We start to understand the impact that reinforcement learning can have on these models, and we begin to understand the transformer architectures, and that unlocks an explosion of innovation that's still going on today. And by the way, the history that I just walked you through, it took me literally a fraction of a second to access using ChatGPT, in case you are wondering if I use this technology in my day job. I do. And so then we get to 2020, and that's when things start to move at an exponential pace. ChatGPT 2 was released in 2019, and even though we internally knew that it was a really big moment, no one in the rest of the world really cared. And then we launched ChatGPT 3, and no one really cared about that one either. And then ChatGPT 3.5 is launched, and that happens in 2022, in November. And that's the moment that things take off. But let me remind you that ChatGPT 3.5 really wasn't that impressive. It couldn't pass the LSAT, it failed the bar exam. It could find you a decent chili recipe, but it was not gonna change the world. But then we released ChatGPT 4 the following year, and 4.0, which followed it, and the capability jump was massive. It doesn't just pass the bar exam or the LSAT, it scores over 80% on both. And then we have another big breakthrough, this one just 6 months ago. This time it was in reasoning. We figured out how to teach the model to think before responding. And we opened up an entirely new scaling curve, which I'll get into more deeply in a minute. But now, suddenly, we've got models that can outperform human PhDs. And so in the span of less than 4 years, we've really gone from basically a junior high school level output to exceeding the capabilities of a highly trained PhD in almost every subject. And so what that means is if you aren't paying attention to AI every single day, and most of you aren't, it's not your day job, your information is out of date. And that's really hard for government officials to wrap their heads around. In government, you all are used to updating your mental models in FIDIPs. And let's be honest, some people in government have never updated their mental model in the entire time they've been in government service. But my ask of you today is to be open to updating your thinking on this technology. And in particular, I want you to be open to the fact that the pace of this technology is being measured by a clock, not a calendar. And so now I'm gonna walk you through this in a little more detail and show you some proof points for some of the pretty bold claims that I just made. So what you're seeing here is the difference in performance between GPT 3.5, which we released in 2022, and GPT 4, released the following year. And on the bottom, you're seeing all kinds of exams that may be familiar to you that test domain expertise. So what you're seeing here is that GPT 3.5 is the blue bars, and it couldn't pass the LSAT, it failed the bar exam, and then you see this massive capability jump in GPT 4, where all of a sudden the model is scoring over 80%, 75% on nearly every model, or every exam that we're giving it. But to go further, what you're not seeing on this slide is with the release of our O3 reasoning model about 3 or 4 weeks ago, every single one of these benchmarks is completely saturated, meaning our models can score over 99% on every single one of these tests. So what you're looking at here is the error rate as the model thinks. So the x-axis here is the amount of time the model spends thinking before answering a question, and the y-axis is the error rate of the model, and both are on a log scale. And what you're seeing here is that the more time we give the model to think, the more accurate its answers become, the less it hallucinates, the more likely you are to be able to rely on the outputs. And we're once again seeing consistent improvements from scaling. So this time, from scaling the amount of time the model takes to think. And unlike data and model size and compute, which were the core ingredients to the first paradigm of AI advancement, there's a ton of room to scale the amount of time we give the model to think before answering certain questions. So if you think about it, today's models, for those of you who play around with them, they'll spend maybe 5 to 10 minutes thinking before answering some types of tasks. And with our deep research tool, which is available at higher tiers in the paid tier levels, it sometimes will take up to 30 minutes to give you an answer. But in the lab, we see that the performance continues to improve as you scale inference. And we see a future where we let the models think for hours or maybe even days before responding. And the results are pretty incredible. So these graphs show gains in capability from our first reasoning model, which we released about 6 months ago, maybe 7 months ago, and our O3 model, which we released about 3 weeks ago. So this is what you're looking at is a capability jump that, again, is measured in weeks, not even really months or years. And what you see on the right is the GPQA. This is an evaluation that tests the ability to solve PhD-level science problems. It's called the Google-proof Q&A because it's designed so that the answers are not easily Googleable or found on the internet. You have to reason through them. And what you're seeing here is that O3 is better than 90% of all PhDs at scientific problems in their field, across every field at once. This is super exciting because we're starting to see scientists, including folks at our national labs, where at Los Alamos and Lawrence Livermore and a number of other national labs, they are using these models very heavily, and they are finding that they can use them to accelerate the fundamental science research that they're doing by really accelerating the timelines using these models. On the middle left, you're seeing code forces. This is a competitive coding exam. O3 score is equal to the 175th best human coder in the world. By the end of this year, we assess that our models will exceed the capabilities of all of the best human coders in the world. And then to the right of the middle is the AIME. That's the qualifying exam for the US Mathematics Olympiad team. You'll see that O3 missed only one question on this exam. And then on the far left, you see a measurement of the model's ability to do real-world coding challenges. Unlike code forces, which asks the model to write brand new code, the SWE bench asks the model to find and diagnose a problem and implement a patch. And so this is kind of like zero-day type patching. And as with the others, O3 is already able to outperform many human coders. So this is why I said earlier that if you aren't paying attention to AI progress every day, your information is out of date. And some of you live in the digital world, and this probably feels, familiar to you. You came to this session because you already care about AI, and you probably get this intuitively. But a lot of folks I talk to in government don't. They really struggle with some of the things that were once true about AI, even as recently as 6 months ago, but are no longer true. So I'm going to spend like 2 minutes and just clarify a few things that are no longer true. We used to think that there was no way to know how the model arrived at its conclusions, and that meant we could never be confident in the outputs. And that's not true anymore. As you will see today, because I'm going to show you in the demos, our O-series reasoning models can actually produce a detailed chain of thought that displays the steps it's taking so that a user can follow along and understand how the model arrived at its conclusions and what information it relied upon. When you work at OpenAI, people love to tell you about how the model's getting something wrong. And I'm sure many people in the audience have examples they can give me of something that the model couldn't get quite right for them. As I mentioned, when ChatGPT 3.5 was released in 2022, it really wasn't that good. That's when most people got curious about it. And they played around with it in a bit. And if you were one of them, you were right if you thought it was interesting but not that transformational. It wasn't reliable, it hallucinated, the outputs were just okay, but they were pretty meh for most things. But 2 years later, and these models are now, as I showed you, routinely exceeding the capacity of human PhDs. They've just gotten much, much better in a very short period of time. We also used to think the models were inherently unreliable. And I'm going to pause here and just note for the record that human beings are also inherently unreliable, and we have figured out how to deal with that fairly well. But we've gotten much, much better at improving the outputs. And as I've explained, the reasoning models have really opened up a new scaling curve by thinking longer. And when we scale the amount of time the models take to think, even by just a few seconds, we see dramatic improvements in the reliability and the quality of what they produce. And if you're thinking, that seems like a really big deal, why haven't I heard about it more? Why isn't that out there? The answer is that the O3 model has only really been out in the world for the last 3 weeks. And people are really just beginning to scratch the surface of what it can do. And the entire reasoning paradigm has only been in the world for 6 months. So, I mean, we're still in the very early stages of figuring out what these models can do. Speaking of scaling, some people thought for a while that LLMs were going to peak, that there was a limit to how much you could get by just adding more data and more compute and trying to get better outputs. And there is some truth to that. We know that by continuing to scale model size, scaling data and compute will eventually become impossible or will have serious limitations. We are already basically saturating the amount of data available in the world without having to create synthetic data, and there's just only so much compute to be had. But we think we found a new scaling curve, and that's what the O series of models, the reasoning models, have really opened up. And they give us they scale by giving the model time to think, and there's a lot of room to scale that. So there are more myths that I could debunk, but the point here is that the things that were once true about AI are becoming untrue at a dizzying pace. And I really want to foot stomp one point, which is that government often feels like using AI is too risky and that it's better and safer to keep doing things the way that we've always done them. And I think this is the most dangerous myth of all. Because if we keep doing things the way that we've always have, and our adversaries adapt to this technology before we do, they will have all of the advantages that I'm going to show you today, and we will not be safer. We need a way to more accurately capture the risk we are taking by staying the course, and that's the risk of the United States government falling behind. Okay, so we're almost to the good part, and just a couple of things up front. Most of how government thinks about understanding satellite imagery started with classifiers, which could do basic object detection and characterization. And then we moved on to the foundation model era. And that's where models could handle more advanced feature extraction across a wide range of classes, but these were still fairly static applications. But we're now in the reasoning era where our LLMs that were not explicitly trained on GEOINT workflows can nonetheless outperform highly specialized models and provide new levels of multimodal analysis. And we're going to prove that through 3 demos today, showing how OpenAI's new series of reasoning models can perform high accuracy localization tasks across both overhead and ground level views. And we're going to see capability here across a wide variety of applications, from building better geospatial foundation models to better conducting sensitive site exploitation to accelerating and automating analytical workflows. So I'm going to move through this fairly quickly. My goal isn't really to go super deep today, although you guys can get my email address and I'm happy to go deep later. But what I really want is to show you what's possible and to broaden your perspective about the range of tasks that this technology can reliably perform. These demos are entirely new. I built them for you, and we intentionally didn't spend a lot of time on them. Everything I'm about to show you is possible with a computer and internet connection and access to ChatGPT. This wasn't customized. There was no specialized training in any way. Lastly, I also want to stress that we do a lot of work to mitigate against misuse of our technology. We are constantly red teaming and reviewing how our models respond to concerning queries, and we have an entire intelligence and investigations team that is monitoring and blocking abuse of our platform, including by state actors. And we publish our reports about this. We've published probably a half a dozen of them at this point, detailing takedowns and malicious actor use of our platform. So despite what I'm going to show you today, we are not allowing our tools to be used for defense and intelligence applications without our involvement, and we limit the countries that we are willing to partner with to a small number of countries who share our democratic values. So, okay. I'm going to go one over. Before I hit play, I'm going to, basically what you're seeing here is ChatGPT at the top left. You're seeing that we're using the O3 model, so this is our most advanced reasoning model. And I'm going to hit play, and then I might pause to highlight a few things as we go. All right. So we're going to start with a basic example of some overhead imagery. We picked this one because it's reasonably difficult. There's not much in the form of distinctive features that the model can immediately identify. So what you're seeing here is the chain of thought. And we're giving it the single prompt to just extract clues, take 3 guesses, and let's see what happens when we let it run. Notice its tool use. It's searching the web to confirm some of its initial thoughts. It's tracing everything the model is thinking about, every issue it ran into and how it overcame it, every task that it identified and executed. It's able to zoom in on elements of the image to check for metadata, to web search, to corroborate what it sees from other information sources. And it correctly identifies the Simpson Desert in Australia. So can you pause the video here? We've done these demos many times. We actually have like a big group of GEOINT nerds inside the company who just absolutely love to test the model's capabilities on these sorts of images. And, it didn't used to be able to get this image right. This was one of the harder ones. We gave earlier versions of the model and it couldn't get this image right. And you're able to see how in basically a span of under a minute, it was able to figure out where in the world this photo was taken. But okay, that's kind of impressive. So let's get a little bit harder. So if you could continue playing. I'm not sure it's playing. There we go. All right, so now we're going to give it a street level example, and we're going to let the model run. And while it does that, I'm going to give you guys a challenge. I would love anyone in here to try to outguess the model. Feel free to shout out a continent or a country if you think you know where this photo was taken. Anybody? Russia, Ukraine. I couldn't hear that one. Pakistan, okay. So we're going to see the same chain of thought. We're going to see tool calling. We're going to see it zooming in on images and trying to make sense of things. It tries to find metadata, but I've taken the metadata out. So I want to flag that we can actually fine-tune these models. This is all off the shelf. These models have only been trained on commercial data, and we still see really incredible performance. So it starts to give you an idea of what could be possible if we actually trained a model to be exquisitely good on your data and with your workflows. But what you'll see here is the clues. It's telling us why it thinks it, and it not only gets that it's Bulgaria, it actually gets exactly where in Bulgaria it is, what district it's in. Now, if you could pause here, we started doing this, running this image with our before we even had reasoning models, and it would only sometimes be able to guess the country. It couldn't go any further than that. But the Cyrillic text was really a pretty big clue because it's a type of text that only is really spoken in Bulgaria. And so we found that it could get that, but this level of detail is really, really new. And it's something that has been a major capability jump in the last 6 months, just between '01 and '03. But okay, this is pretty obvious, and you had a lot of clues in that one, and some of you made guesses that were in the right corner of the world. But now this is my favorite example, and this one is really, really hard. So go ahead and hit play again. So we are going to give the model the same prompt and an image, and I'm going to give you all 30 seconds. Continent, country, there's no man-made anything in this photo. Missouri. Your backyard. I did not, this one blew my mind when I first saw it, because I did not think that it was going to be possible to identify where this photo was taken. Florida? Florida, any other guesses? So what you're seeing here is that the model is actually identifying the genus of the bunny rabbit. It is actually identifying what kind of grass. It's doing soil analysis. It is honing in on the lighting and what time of year it must be. And it actually correctly identifies that this photograph was taken at Cape Canaveral. This photograph was actually one of the photos of the day from the NASA website, and it was taken at Cape Canaveral. And I have to tell you, this one just blew my mind because, what you're seeing here is the native capability of these models with no specialized training. And you saw today an overhead, a street level, a very hard close-up. The model is correct every time. And we are really excited to see what our industry partners build with this technology. And we're especially excited to partner with government to find ways to apply this frontier research towards some of the hardest GEOINT problems. So, okay. The thing I kind of want to leave you with is the only thing that you and your adversary have in equal measure is time. And it's very clear that AI tools are now mature enough and reliable enough to save you lots and lots of time. The state of Pennsylvania actually measured this just a couple months ago. They did it over the span of a year, but the results came out a couple months ago, and they gave ChatGPT to their government workforce, and they measured how much time it saved over the course of a year. Now, these were not whiz-bang AI native 21-year-olds. They were state government bureaucrats, and anyone want to guess how much time it saved them? Any? 8 hours a week. A whole day, just with access to ChatGPT. But okay, I work at OpenAI. I, of course, am going to tell you everybody needs to be using ChatGPT. But I actually don't care which, if anybody from our sales team was here, they would drag me off the stage at this point. I don't care which tool you use, as long as you're using something. Because the one thing we know from leveraging these tools in the corporate environment and seeing how companies are using these tools to become AI native organizations, the number one predictor of success in AI adoption in an organization, number one, is how much their leadership is using it. That's based on our experience with over 90% of the Fortune 500 companies, leadership use. Direct correlation between leaders who actively use AI in their daily work and whether their organizations succeed at adoption. So now I'm going to give you a little bit of a glimpse into the future and get you thinking about what that might look like in the work that you all do. So this is a framework that we've developed internally. This isn't a thing that we've published, but I think it's a helpful way of thinking about the journey of progress between where we have been and where we are going. We don't think that the arrival of AGI, or artificial general intelligence, is going to be black and white. Like one night it's not here and then you go to bed and you wake up and the next night there's AGI. That's not how we think this is going to happen. Internally, we think about it in 5 levels. Level 1 was really just the chat era. It was, you put in something, the model immediately spits out an answer. That was what ChatGPT originally was. Level 2 is human-level problem solving, AI that can do more advanced tasks by thinking harder, and that's what we really unlocked 6 months ago with the introduction of the first reasoning model. And level 3 is systems that can take actions, AI that can reliably carry out complex tasks in the real world. And I want to say just a bit about our partnership with the US National Labs, because I think that brings us to the very beginning of what we think of as level 3. In January, we announced a partnership with the National Labs to deploy our models, actually physically deploy our model weights, our kind of crown jewels, inside of US government physical hardware architecture, so inside of the high-performing computing environment that the labs own. And this is the first time OpenAI or any frontier model developer has actually moved model weights inside of a secure government environment. And in just 4 months, we have gotten our entire inference stack up and running on their system, and they're beginning to automate the tasks associated with scientific discovery. And I expect that we'll have results that we can share within the next few months, but the early indications are very clear that we are going to dramatically shorten the timelines for net new scientific discoveries. And one of the things that I want to leave you with is really about the fact that this is the first time in American history that a technology of this consequence is being developed exclusively by the private sector. If you think about every other moment that something this significant was happening, whether it was electricity or the steam engine or the internet or nuclear fusion, somebody in the government, typically DoD, DARPA, had a foothold in what was happening. They were a stakeholder in bringing the technology to market. And that's not true about AI. And what it means is that we are going to have a different type of partnership with the US government and with allied governments that share our values around bringing government in to have a seat at the table. Because there are some things like general productivity that you guys absolutely can and should buy off the shelf. The commercial solutions are great. Don't try to customize it. You're wasting time. But there are some things that we really need models to be able to do that there is no commercial application for in the national security context. And what that's going to look like is partnership with the leading frontier labs. It's not going to look like something different than that. And so I'm lucky and privileged to be able to lead the work that we're doing at OpenAI to do exactly that. I'm excited to be talking to NGA and other parts of government about how we can, transform the way they work. And for those of you who are inspired or got new ideas listening to this today, I'm happy to talk to you. Thank you so much for being such a great audience. I hope we achieved what we set out to do and left you knowing a little bit more than you did when you got here. Thank you.